data flow model. That question will ask us like explain the ARM code data flow model with a need diagram. See the diagram that we can consider as a data. Then data will be connected to the read writer and then instruction decoder. That instruction decoder means it can translate the instruction before they execute. That's the function of an instruction decoder. Then you can give the read and write. Then register first is connected to the read is direct sign extended using. Then write will be giving a reverse in direction because of writing a code. Then instruction decoder that gives separate because of translating a decoding. Then give the barrel shifter ALU address register incrementer then address MAC that same as it is. That you have should write the diagram in the examination when you will ask where ARM coded flow model. So the explanation will be the ARM core functional units is connected by data buses. Means that lines are buses that shown in the figure 1. The functional units are the data buses. Then where the arrows are represented as a flow data, that lines represent as a bus, boxes represent as a operation unit or in storage unit. That boxes represent what is the operation unit or storage units, and then lines are buses that data flow model that boxes represent. Then go through the data decoder, instruction decoder. Instruction decoder is the transit of instructions before they're executed. Before their execution, that's why you give the separate. Then go to the next one is the ARM processor, like an RISC processor used to load and store architecture. Then load instruction. That load instruction means copy data from the memory to registers, and conversely the store the instruction of copy data register to the memory. That means you have to load the instruction, then conversely store the instruction of a copy data from the register onto the memory. That is a function. Then there is no data processing instruction that directly manipulate the data into memory. Then ARM instruction is typically having a two sources of registers, RN and RM, that is single destination registers, and RD. Source operand or read of registers as using internal buses A and B respectively. Then arithmetical logic unit or MAC multiple accurate unit that used to registers value from RN and RM that in A and B buses of computer results. Then data processing instruction write a result as an RD directed to register file. That load and store instruction using a ALU regenerate address that held an address registers and broadcast of an address bus. Then one important features of the ARM is the register RM alternatively can be pre-processed in the barrel shifter before they enters the ALU. Then after passing through the functional units, the result already returned back to the register file using a result bus. Then for load and store instruction, they are incrementing update address register before the core reads and write the next register value from the next sequential memory location. That is about the ARM core. Then go through the registers. What is the registers means? That explain briefly about three active registers available in user modes, or then with a neat diagram explain different general purpose registers in ARM processor. That shown in the figure the see here R0 to R15 that will shown. Total 18 registers will be there. See here there are up to 18 active registers here. Then 16 data registers and 2 processor status registers. Then data registers are visible to program to R0 to R15. Then ARM processor is a 3 register assigned in particular tasks R13, R14 and R15. That R13 and register R13 and register R30 is traditionally used to stack pointer. That you should write that point you have to mention. Then store the head of the stack point is current processor mode. Then go to the register R14. That register R14 is called as a link register. That have to core puts the return to the address whenever called to subroutine. Then R15 is a register program counter that contains address of the next instruction to be fetched by the processor. In addition, that is 16 data registers. There are two program status registers. Current program status registers means CPSR. Then program status register means saved process registers, that SPSR. Then next question is the CPSR. Based on CPSR, explain the various speed of current process registers and then a neat diagram. That diagram is shown here. See, then that considers fields and flags. That fields basically starts with the 4 last 28 29 30 31. Total 31 bits will be there. See here. So in flags and status extension, that controls you have to write as it is here. Will be there that you have to write. Then that CPS are divided into 4 fields, that 8 bits wide and flag status extension control. means flag status and extension control should write that current design extension status fields are reserved for the future use. The current filter contains a pre-processor mode and state interrupt and a mask bits. Then flag field contains a conditional flags. That big pattern that process is not don't want that much. You should write just points and a diagram. That's enough. That give mass full mass. Then CPI submit is a 5 and T is equal to the processor thumb state is a T is equal to 0. The process of a harm state. Then CPSR has a 2 interrupt mask bits 7 and 6. So that control masking interrupt request, that fast interrupt request. And condition flag are updated. The comparison request ALU operation specify the S instructions suffix. Then subtract instruction result is a register value of 0. Then set is a flag in the CPSR set. That was the registers. Then CPSR current status registers. Then go through the processor mode. That processor mode means the various modes of operation in ARM processor. That each processor has mode of either privileged or non-privileged. That privileged mode read and write access with CPSR, but non-privileged is only read access. That should write you should write that control field and CPSR, but allows to read and write access in conditional flags. And even a 7 processor modes is a 6 privileged modes and 1 non-privileged mode. That privileged mode is abort and fast interrupt request. That interrupt request supervisor and system as undefined. Non-privileged mode is users. Then the process is abort mode when even failed with attempt to access the memory. Then fast interrupt and interrupt request modes that corresponding to interrupt levels available in the RAM processor. Supervisor mode, that processor is after reset is generally the mode. Then operating system is a kernel operates in the system mode. The special version used to mode allow to full read write access to the CPSR. The undefined mode that used to processor encounter instruction. That undefined mode are not supported implementation. Used to program and application. That's why you have to using process mode. That most probably they will ask. Then go through the bank register. Bank register is simple. That you should write there some simple diagram that ARM register set. That R0 to R15. That PC CPSR you have to consider SPSR figure. Then SPSR fast interrupt request at FEIQ. Then IRQ interrupt request supervision undefined and abort. You have to mention that complete ARM register set. That allow to 37 register files. That totally here 37 register files will be there. So then that as a 20 register is added from the program times. Different type of register is called as a bank register. They are available only the process particular mode. That you should write the R13 R15 and SPSR about. Then bank code register particular directory underline character post fixed to the mode economy. Then every processor mode is except a user mode that can change the mode writing directly mode bits of a CPSR. Then all privileged modes except system having a set of associated bank code register that are subset as the main 16 registers. Then processor mode is changed bank code register from the new mode by replacing the existing registers. And the processor mode can be changed by programs by return writes directly by CPSR when the processor code is privileged mode. Then following the exception or interrupts cause the mode of a change, the reset that request the fast interrupt, software interrupt, data abort and prefetch abort and run. The same as it that before we learned this what processor here also the same thing you should write. Then another one diagram will be change mode of an exception. That figure 2 you should write that the 3 points user register replace the 13 14 respectively. Then R14 then return the address of an R13 IRQ contains stack pointer interrupt request that mode. Then last question is in pipeline. Write explain the various types of a 3 stage of pipeline. That ARM processor instruction whenever the instruction is break to into small units that called as an pipelines. That right, that is a definition of a simple definition of a pipeline. But pipeline mechanism speed execution by fetching next instruction for each other instruction being decoded and executed. That figure only shown fetch, decode and execute. Means fetch load the instruction in memory, decode means identify the instruction to be executed. Then execution process instruction write the result back to the register. That is the function. Then figure to illustrate the bypass same as it is you have to write. Then see here the second diagram that fetch, decode, execute. That should write. Then this is the important diagram. Fetch, decode, execute, memory and write. Fetch, issue, decode, execute, memory and write. You should write that 3 diagrams and on total 4 diagrams should write. Then first cycle fetch the add instruction, then go through the sub instruction, add instruction, then CMP instruction, then again the sub instruction and add instruction. That total that instruction is filling a pipeline. Then pipeline is a ARM instruction family differs, that should write. Then write the characteristic that ARM pipeline is not processed instruction until it passes completely through the change ARM 7 pipeline. That's it. Right.